In this video, we'll go over the average speed and average velocity. So we're gonna go over the difference between both of them. But before going to average speed or average velocity, we need to go over basic definitions like what is the speed or uniform speed or variable speed. Then we can go to the topic called average speed. So those are the basic things we need to know before we move forward with average speed. And then we're going to solve some numerical problems on average speed and average velocity. And one of the problem I'm going to go over is this one over here. And let's start with the concept. Okay, so first of all, the first thing I'm going to go over is speed. So first of all, we need to know what is a speed. Okay, so speed is basically the distance traveled by a body per unit time and is known as the speed of a body. Okay, so let's say speed. So it is equal to distance traveled, say, by a particle or a body, any body, over time taken. Okay, so the distance traveled by a body per unit time is known as the speed of the body. Okay, and the units for speed, and we know the CGS unit for distance is centimeter and time is second. So unit for speed is centimeter per second in CGS and meter per second in SI unit. Okay, and the other thing is the properties, like speed is a scalar physical quantity. So speed is a scalar quantity. Okay, and it has only magnitude, no direction, so that's why we call it scalar. And speed of a body is always positive. Okay, it can never be negative because distance travel is always positive, so it can never be negative. All right, so that's the speed. So next concept that comes in is what we called uniform speed. Okay, uniform speed. So uniform speed means when a particle or a body is said to have or said to be moving with a uniform speed if it travels equal distance in equal interval of time. Let's say if a body is moving 5 meter in every second. Okay, so it's moved 5 meter the distance and time taken is 1 second, and then again it's moved 5 meter and time taken by it is 1 second. So every time it's uniform, it's not changing, it's same distance over time, same distance over same amount of time. So then we called speed as a uniform speed. And if we graph it, the graph will be a uniform graph that will look like this. Let's say we got time in this direction and distance, let's say d, in this direction. So time, okay, and the distance. So graph will look like a uniform straight line like that. So the intervals will be the same. Okay, so that's what called uniform speed. So hold on, so we are moving to the average speed because I want to go over these concepts before we talk about average speed, because these are really important to know before we learn about average speed. Okay, so let me make some space over here. So next thing is variable speed. Okay, so we need to know about variable speed. So in uniform speed, distance travel is same over the same amount of time it spends, In variable speed, a particle or a body is said to be moving with variable speed if it travels unequal distance in equal interval of time. Let's say it's moving toward in this direction. It's moving unequal distance. Like first second it traveled that much distance, but in the second time the time is again 1 second, but the particle moved only this small distance. Okay, so the distance traveled in a same amount of time is not same, it's unequal. And when we find the speed of a body with these, we call it variable speed. So it can be written as like it's traveling an equal amount of distance but in unequal amount of time. So body move, let's say 5 meter, and it spend 1 second, and next 5 meter it spend, let's say 2 seconds. So it take body to like 2 seconds to cover 5 meter, the second interval. Okay, and when we measure the speed in this case, we called it a variable speed. All right, and now we're gonna go to our main topic, main concept, which is average speed. All right, so average speed is when a body moves with variable speed. Okay, it's changing, either it's unequal intervals or unequal amount of time. So whenever the speed is a variable speed, or whenever a body moves with a variable speed, then the average speed of the body need to be calculated. Okay, and we calculate it as so average speed of a body is going to be the ratio of the total distance traveled. So it's going to be total distance traveled by the body over total time taken. Total time taken. Okay, and that's called your average speed. Now there is different situations arises when we are calculating average speed, because you see there are two situations here. In this case the distance is unequal but time is equal, but in second case the body is traveling with equal intervals of distance but in different amount of time. So different situations are here. So average speed depends on those different situations. So we're gonna go over those different situations for average speed in next. Okay, so let me make more space over here so we can go over that. So let me write down like average speed in different situations. Okay, very important. That'll help you to solve a lot of numerical problems. Okay, so first of them, let's talk about first situation. So I'm gonna write the first situation over here. So let's say a particle traveling different distance with different speeds. Okay, so first situation is a particle traveling different distances with different speeds. Okay, so that's the first situation. All right, so let's say if the particle travel s1 distance in distance with v1 speed, then it travel s2 distance with v2 speed. Okay, so what should be the time taken here? So time taken by in this interval is going to be distance over speed, and the time taken to cover this interval is going to be t2, let's say going to be s2 over v2. So in this case, the total time taken, you remember the average speed was total distance traveled over the total time taken. So total distance, total time in this case is going to be, I'm gonna write it down, total time is going to be t1 plus t2. Okay, and the total distance traveled, how about total distance? Total distance is going to be s1 plus s2, because s1 is the first interval, s2 the second. So total distance is s1 plus s2. Okay, so, and this can be also written as, so t1 is s1 over v1 plus s2 over v2. All right, so average speed in this case is going to be average speed of the particle, let's say v average, if you remember, was total distance over total time. So this is going to be s1 plus s2, because that's our total distance, over total time is going to be s1 over v1 plus s2 over v2. All right, so that's the formula for average speed. Now let's say there's a case, let's say if the particle is traveling the same distance. Okay, so let's say s1 is equal to s2. All right, and let's say both are equal to s. I'm gonna call it a bigger s over here. So what will happen? So v average, the formula will look like the average speed. So s1 is equal to s2, so both are s, so s plus s gives me 2s over here, divided by s over v1 plus s over v2. And when you, let me solve it here. So let's take s as a common factor, so I take s out, so I left with 1 over v1 plus 1 over v2. Okay, and this s will cancel this s over here, so that gives me 2 over, I'm going to write the common denominator, so v1 v2 is going to be v1 plus v2, and denominator go to the numerator, so it becomes 2 into v1 v2 over v1 plus v2. So that'll be the formula to find the average speed when a particle traveling different distance with different speeds. So you only need to plug in the speed value over here and you'll be good to find the average speed. Okay, so that is a one scenario, or that is a one situation. Okay, so let's go over the second situation, what that will look like. Let me find some space here. All right, so let me write down the second situation here. So that is if a body travels equal distance with different speeds respectively. Okay, so let's say if a body travels equal distances with speed v1, v2, v3 and so on, let's say 3 speeds, like for example it travel that much distance, let's say 5 meter, but speed is a v1, and next 5 meter but speed changes, it's v2 now, and third one is again 5 meter but speed is v3. So particle or a body is traveling equal distance but different speeds. Okay, so how the formula may look like in that case, it's going to be exactly the same how we did, but it will be v average is going to be, you're gonna do the same thing, s1 plus s2 plus s3 over, it's going to be s1 over v1, so total distance over total time, s2 over v2 plus s3 over v3, so on. Okay, so that can be as distance is same in each interval, so this gives me on the top as 3s, and these all becomes s, so I'm gonna take s out as a common factor, so left with 1 over v1 plus 1 over v2 plus 1 over v3. This s will cancel out, and here we're gonna find the common denominator, which is going to be it's going to be v1, v2, v3, and it becomes, in the numerator becomes v1 v2 plus v2 v3, or yeah, v3 plus v1 v3, and then we rearrange it, it becomes 3 into v1 v2 v3 over v1 v2 v1 v3 plus v2 v3. So that will be the formula in that case. Okay, so let's go over third situation. So there is one more, and then we're gonna go over one example. Okay, so third situation is going to be a body or a particle moving with different speeds in different intervals. Okay, moving with different speed in different intervals, different speed in different intervals. Okay, so let's say the body or the particle is moving with these speeds, let's say v1, v2, v3, and so on, and the time intervals are t1, t2, t3, and so on. So the total distance traveled, remember, speed is distance over time. Okay, so distance s is going to be speed into time. So what should be the distance traveled? So total distance is going to be v1 t1 plus v2 t2 plus v3 t3. So that's the total distance. Okay, I'm gonna write it here, total distance, and the total time is going to be t1 plus t2 and t3. So what should be the average speed here? So average speed is going to be v1 t1 plus v2 t2 plus v3 t3 over total time, which is t1 plus t2 plus t3. Okay, so if let's say time is same, so if we bring another situation into this, so time interval is same, like t1 is equal to t2 is equal to t3 is equal to some time t. So what will happen here, so all these times are same, so we can take out the time factor out, left with v1 plus v2 plus v3 divided by t plus t plus t is 3t. This t will cancel this 3, so average speed will become v1 plus v2 plus v3 over 3. So it looks like the average we find for numbers. Okay, so those are the three different situations they can ask you problems to solve on, okay, for the average speed. So let's go over one example over here, that way you know the practical application of these formulas. Okay, so let's go over one example. So let's say a car covers first half of the total distance. Let's say a car travels first half, I'm gonna write down first half of the total distance with speed 36 kilometer per hour, and second half, so second half with the speed, let's say 54 kilometer per hour. So, and they said what will be the average speed, or find the average speed. Okay, so what we got here, so always look into what is given to us. So they gave us v1, which is 36 kilometer per hour, and they gave us v2, which is 54 kilometer per hour. Okay, so v average, remember the formula, if the distance, now see, first half, second half, that means the distance is same. So this is, if this is the total distance, this is the half, so distance is same. So this is s, this is s. So what was the formula for average speed? So v average is going to be 2v1 v2 over v1 plus v2. We don't even need to know the distance, we can find the speed here. Okay, so you plug in these number and solve it, you get the answer. It's going to be 2 times 36 times 54 over 36 plus 54, and when you solve it, you get around 43.2 kilometer per hour. Okay, so that's how you can use the formulas to solve the numericals. Okay, so different situations depends on different problems, so you can use those situations I was talking earlier to solve different problems. Okay, now let's move to the next concept, which is average velocity. Okay, so average velocity, which is a little different than the average speed. Okay, so average speed is the displacement of a particle or a body per unit time. Okay, so first of all, let's talk about velocity. What is the velocity? So velocity is going to be displacement of a particle or a body per unit time. So displacement over time. So displacement over time. Okay, so that's your velocity. Okay, and velocity is a vector quantity. Remember, displacement is a vector quantity. So first thing is velocity is a vector quantity. There is a direction. Okay, direction will be involved. So as you remember, displacement can be positive, negative, or zero. So does the velocity. So velocity of a body may be positive, negative, or zero. Third thing is, so if you remember, distance is greater than or equal to the magnitude of the displacement. That means velocity, speed is going to be greater than or equal to the velocity. So the big distance is, speed is a scalar, velocity is a vector. Speed is always positive, but velocity can be positive, negative, or zero, because it depends on displacement, which can be positive, negative, or zero. And the other thing is, distance is greater than or equal to the magnitude of displacement, and speed is going to be greater than or equal to the magnitude of the velocity. Okay, so the second thing, as we learned in speed, like uniform speed, same thing with the velocity. So uniform velocity, let's go over uniform velocity first of all, find the speed, and then we're going to talk about average velocity. Okay, so uniform velocity, that means a body or particle has an equal displacement in equal interval of time. Okay, so let's say moving in this direction, same displacement and same interval of time, let's say 5 meter, 5 meter, 5 meter, took 1 second here, took 1 second here, took 1 second here, and they're moving in this direction. Okay, so in this case, velocity is uniform. Okay, and how about non-uniform? Let's say if the particle or body is said to move in a non-uniform or a variable velocity if it has equal displacement in unequal interval of time, like the displacement is 5 meter, but here it took 1 second, and here it took 2 seconds, and here let's say it took 3 seconds to cover this 5 meter, then it's non-uniform or variable velocity. Okay, or if it has unequal displacement, like this is 5 meter, this is 1 meter, this is 3 meter, right? 5, 3, 1, and time is same. Okay, unequal displacement but in equal interval of time. It took 1 second, 1 second, 1 second here. Then this velocity is going to be your non-uniform velocity. A third case can be if it moves with a constant speed but changing its direction of motion. Okay, its same speed. Okay, 5 meter, let's say 5 meter per second, but it changes direction. Okay, so there is a change in the direction, then it's called variable or non-uniform velocity. Okay, so those are the basic concepts you need to know before you go over average velocity. So average velocity is going to be total displacement. I'm going to write it down. So it's going to be total displacement over total time interval. Okay, and now let's go over one example which I wrote before, just to find average speed and average velocity and see the difference, like what is the difference in both of them in real life. Okay, so let's say we got this problem. It says a girl walks from her house to the park, which is 1 kilometer away, and she reached the park in 30 minutes, and then she walks back to her house and stops after 15 minutes at the market, which is half kilometer away from the park. Now they say calculate the average speed and magnitude of average velocity during the whole journey. So let's set it up. So what they gave us. So let's make a picture here. So let's say her house is here, origin, I'm gonna say origin, and a park is here. Let's say park here. So it's traveled from her house to the park, which is 1 kilometer. So this total distance here is 1 kilometer. And she traveled this distance in 30 minutes, right? And then she traveled back towards her house, but she stopped at the stopped at the market, which is half kilometer from the park. So this is park here, and this is market. I'm gonna mark it A as market, and which is 1/2 kilometer from the park. Now we need to find the average speed and average velocity. Okay, so let's go over it one by one. So first of all, I'm gonna find the average speed. Okay, so average speed, remember, is equal to total distance traveled over total time. So in our example, the total distance traveled by this girl is 1 kilometer, and then she came back to the market while she was traveling back home. So 1 kilometer plus half kilometer. So 1 kilometer plus 0.5 kilometer. Okay. And the distance traveled, so she spent 30 minutes going that way, 30 minutes, and then she came back halfway here in 15 minutes, so plus 15 minutes. Okay, so this is going to be equal to, total distance is 1.5 kilometer, and 30 minutes can be written as 45 minutes, and we can change that to hours. 1.5 kilometers, so 45 over 60 hour, sorry, yeah, hour. You can say 3 4 goes to the top, 6 over 3, so is equal to 2 kilometer per hour. So this is going to be her average speed, 2 kilometer per hour. Now let's find out her average velocity. So average velocity is going to be total displacement, not the distance. So total displacement over total time. Okay, so her total displacement is going to be, remember, the final distance minus the initial position. So it's, or the initial final position minus the initial position. So it's going to be 1 kilometer minus 0.5 kilometers. So that's our final position here, and that was initial position. So 1 kilometer over 0.5 kilometer. Basically the distance between initial and the final position, that much. So that is her displacement OA, which is 1 kilometer minus this half kilometer. Okay, over the total time, and time is again the same, 3/4 of an hour, which is 45 minutes. I'm gonna write 45 minutes here. And that is going to be equal to 0.5 kilometer over 3/4 of an hour. So you can convert that, I already did over here. So it's going to be equal to, when you solve it, 0.67 kilometer per hour. You see, there is a difference between average speed and average velocity, because average velocity depends on the displacement, and displacement can be less than the total distance traveled. Okay, so there is one thing we learned: the average speed and the average velocity of a particle are equal if it travels in a straight line without changing its direction. Okay, now in this case, first it traveled in this direction, and then the girl walked backward in this direction. So there is a change in direction. That's why they are different. But if they're traveling in a straight line, there is no change in direction, then average speed and average velocity are equal to each other. Okay, and now if average speed of a particle is greater than the average velocity, if it travels in a straight line but changes its direction of motion. Okay, so those are the few things you can learn from this example too. All right, so thanks for watching the video, guys. I'm gonna try to solve more numericals maybe over this next time, or go over some other concept. Thanks for watching the video. Please share and subscribe to the channel so that you won't miss any video. Thank you, really appreciate. Thank you. Have a good day. Bye bye.